Alright, so let's take a look at some of this derivative stuff here. It says determine if the indicated derivative for the following, or determine the indicated derivative for the following functions. Alright, so we'll start with that first one up here. It says find the second derivative if y equals this. Alright, so this is just a simple power rule. Okay, and the way the power rule works is you bring the exponent down in front, and then you subtract 1 from the exponent. So if you had y equals ax to the n, the derivative of that is you bring this down to n times a, and you subtract 1 from the exponent. Okay, so here I'd bring that 7 down in front. 7 times 3 is 21, x, and then we lower 1 from the exponent to the 6th. Bring the 5 down in front. 5 times 4, 20x to the 4th. Bring the 2 down in front. 18x to the 1st minus 2, okay, because this is like a 1 up here. So bring the 1 down in front, x to 0 just becomes 1. So that would be the first derivative, and then you just have to do this the second time. Okay, so here we bring down the 6 in front, and we'll wind up with 126, lower the exponent by 1, x to the 5th, minus 80x to the 3rd, plus 18. And that would be our second derivative. All right, let's go to question 2 here. Find the third derivative of this problem. Well, first things first, when you have things written as fractions here, I would bring those things on the bottom up to the top. So I'd rewrite this as y equals 2x to the negative 2 minus 4x to the negative 1. Okay, that's the same problem, just bringing those things up to the top. And then we take the derivative using that same rule here. So again, you bring your exponent down in front. Negative 2 times 2 is negative 4x. You subtract 1 from the exponent. Negative 2 minus 1 would be negative 3. Negative 1 times a negative 4 would be a positive 4x. And then subtract 1, so that would be negative 2. So that's the first derivative. We do this again to get the second derivative. Negative 3 times negative 4, positive 12x to the negative 4. Okay. Minus 8x to the negative 3rd. We're just subtracting 1 from those exponents. And then the third derivative, negative 48x to the negative 5 plus 24x to the negative 4. And then last step here, since they wrote it as fractions in the original problem, I would just switch this back to be those fractions. We have positive exponents, so it's be negative 48 over x to the 5th plus 24 over x to the 4th. And that would be our third derivative here. All right, let's look at number 3 here. So again, we want to find the third derivative of y equals 4 times cosine of x. Okay, so y equals 4 cosine x here. All right, so first things first, you're going to have to remember the derivative of cosine. Derivative of cosine is negative sine x. So this is really just negative 4 sine x. That would be the first derivative. Second derivative, we just take the derivative of that. Derivative of sine is just cosine. So derivative of this sine here, I just write as cosine x. Okay, and then the third derivative is negative 4 times the derivative of the cosine, which we said was negative sine x, which that's just the same thing as negative times a negative is positive 4 sine x. There you go. All right. Okay, find the second derivative of this here. So we have y equals that. Okay, so f of x equals e to the 6x. Now with e's, this is a little bit tricky here, the way that you take the derivatives. But basically what I like to kind of think of this as is if you have f of x is e to the u, to take the derivative, or I should say f of u here, the derivative of f of u, the way you do is this: you keep e to the u times the derivative of u. Okay, so if I want to take the first derivative of this, this is like e to the 6x, we keep that the same. Okay, just e to the u, we keep it originally, times the derivative of this top part up here. So times the derivative of 6x, well, that would simply just be 6. So f prime of x is just 6e to the 6x. All right, so then if I go ahead and take the second derivative of this, this is going to be 6 e to the 6x times, again, the derivative of the top, which is just 6. So f double prime of x here is going to be 36 e to the 6x. Okay. All right, let's take a look at number 5 here. So we want to find the fourth derivative of f of x equals 8x cubed minus sine x. All right, so let's start with the first derivative. Okay. So again, then we use that power rule, bring down the 3. This becomes 24x, subtract 1 is 2, minus the derivative of sine of x is just cosine of x. Okay, that's the first derivative. Then we do the second derivative here. 2 times 24 would be 48x to the 1 now. Minus the derivative of cosine is negative sine x. Okay, so that's the same thing as just plus sine x. Then the third derivative here, we do this again. Bring down the 1. 1 times 48 is just 48. And then the derivative of sine is just cosine. Okay, and then the fourth derivative here, so fourth of x. Well, derivative of just a constant is 0. Okay, so it's 0. Derivative of cosine is negative sine x. So the fourth derivative here is just simply negative sine x. Okay. All right, question 6. We want the second derivative of y equals tan x here. Okay, so y equals tan x. What you have to remember is derivative of tan is secant squared x. Okay, so you'll have a bunch of the different trig derivatives that you should have memorized. So tan is going to be secant squared. And then we want to do the derivative of this. Well, this one's a little bit trickier here, and I'm hoping that you've done chain rule in school. You know what? I should look at your formula sheet here. Yeah, you've done chain rule because you're going to need that for number 7. Okay, so let me go back to this one. Okay, so I would think of this problem as really being secant x squared, because then to do the derivative of this, I'm actually going to apply the chain rule. So the chain rule is where you take this exponent, bring it down in front, so it becomes 2 secant x. You lower the exponent by 1, so it's really 2 secant x to the first, okay, times the derivative of the inside here. So the derivative of secant, again, if you look at those formulas, derivative of secant is just secant tan. So this would be times secant x tan x. That's the derivative of secant here. So we can rewrite this thing then. The second derivative is 2 secant x times secant x. So if I took secant x times secant x, that's secant squared x times tan x. And that would be my second derivative here. All right, let's look at this one, 7. We want to find the third derivative of this big function here. So we have f of x equals 3x plus 4 to the 5th. So again, we apply that chain rule. Okay, chain rule. We're going to bring this down in front. So we get 5 times 3x plus 4. You lower the exponent by 1, so that's 4. And then you take the derivative of the inside. Derivative of that whole thing would just be 3. Okay, so then this would be 15 times 3x plus 4 to the 4th. And then we want to keep going here because we need to find the third derivative. So let's start with the second derivative. So same thing. Bring that 4 down in front. 4 times 15 is going to be 60. You keep everything inside. Lower the exponent by 1. Times the derivative of the inside. So times 3 again. So 60 times 3, that's going to give us 180. 3x plus 4 to the third. Okay, and then we have to do this one more time here to find the third derivative. So same thing. Take your exponent, bring it down in front. 180 times 3 is going to be 540. 3x plus 4 squared times 3 here. So the third derivative of x is going to be 1620 times 3x plus 4 squared. All right. Okay, so let's take a look at this next one over here. We want to find the second derivative if y equals x times sine of x. Okay, so for this problem here, it's actually a product rule. Okay, so the product rule, when you're doing this out, if you have f of x, some function of x times another function of x, to find the derivative, you do the first times the derivative of the second plus the second times the derivative of the first. Okay, so here if I'm going to take the derivative of this, well, I take the first, which is just x, times the derivative of the second, so times cosine x, plus, and then I take the second, which is just sine of x, times the derivative of the first. Well, the derivative of x is just 1. So that's my first derivative there. Okay, but we want the second derivative. Okay, so the second derivative. For this part, I need to do the same thing. So it's first times the derivative of the second. Derivative of cosine is negative sine x, plus the second cosine of x, times the derivative of first. Derivative of x is just 1. Okay, so that's that. Plus, now we need to do the derivative of this part. Derivative of sine is just cosine x here. So our second derivative is going to be negative x sine x. 1 cosine x plus 1 cosine x becomes plus 2 cosine x. And there's our answer. All right. Let's look at number 9 here. So it says find the third derivative if y equals the ln of 3x. Okay. So y equals the ln of 3x. Okay, so for this problem, when you're dealing with ln's, if you have y equals 1 over, let's just say y equals the ln of u. When you're taking the derivative of that, what you do is you do 1 over u times the derivative of u. Okay, so for this would simply be 1 over 3x times the derivative of that 3x, would simply just be 3. Oh, well, 3 over 3 will just reduce down, so that's really just 1 over x. Okay, so that's the first derivative. Then we need to take the second derivative. Well, remember, 1 over x is the same thing as x to the negative 1. So now I'm going to apply that power rule here. So I'm going to take that negative 1, bring it down in front. So negative x to the, and then you subtract 1 from the exponent, negative 2. Okay, there's my second derivative. And then the third derivative, again, bring down that negative 2 down in front. So negative 2 times a negative 1 is a positive 2. X, and then you subtract 1 from the exponent. So negative 2, that becomes negative 3. And then I would just rewrite that with positive exponents. So that's 2 over x to the third. And that would be my derivative there. All right, number 10. Find y, the fourth derivative of y, if y equals sine of 6x minus 3. Okay. So we have sine of 6x minus 3 here. Okay, so to take the derivative of something that looks like this, we have to do first the derivative of sine, which would be cosine 6x minus 3. So the derivative of sine just becomes cosine. But then you need to multiply it by the derivative of the inside. So the derivative of 6x minus 3 is just 6. So this is really 6 cosine 6x minus 3. That would be my first derivative. Then we have to do this again. So second derivative. Okay, so again, we take the derivative of this, so we can leave the 6 here. Derivative of cosine is going to be negative sine. So this would be negative sine 6x minus 3 times the derivative of that inside again. So the derivative of this always going to be 6. And so this simply comes out to be negative 36 sine of 6x minus 3. Okay, and then the third derivative, we're just going to repeat this pattern here. So negative 36, derivative of sine is cosine 6x minus 3 times 6. Okay, and so we have to write this out then. That's going to be negative 36 times 6 is negative 216 cosine of 6x minus 3. Okay, and then we need to do the fourth derivative. So fourth derivative, again, same thing. Derivative of cosine is going to be that negative sign. So, you know what, I'll just write it out. So times negative sine 6x minus 3 times the derivative of the inside is 6. Okay, so 216 times 6 is 1296. And a negative times a negative is positive, so it's positive 1296 sine 6x minus 3. Alright, so let's take a look at the next one here. Oh, I don't know what happened. There we go. Okay, the video just went out for a little bit. Number 11. So it says, find the second derivative if f of x equals x over x plus 1. Okay, so this is going to be the quotient rule here. So, you know, maybe I should write out what the quotient rule says. So if you have f of x over g of x, okay, let's just call that y. The derivative of that is you're going to take the bottom times the derivative of the top minus the top times the derivative of the bottom. And you're going to put that all over the bottom squared. Okay, or some people can write this as g of x squared. Alright, so here we have that f of x equals x over x plus 1. So the first derivative of this, I'm simply just going to take the bottom times the derivative of the top. Derivative of the top is just 1. Minus the top times the derivative of the bottom is also just 1. All over the bottom squared. Okay, so x plus 1 times x is just x plus 1. Minus x all over x plus 1 squared. Okay, so x and a negative x, that crosses out, so it's just 1 over x plus 1 squared. Alright, then I'm going to take the derivative of that. Now remember, this is the same thing as x plus 1 to the negative 2. So I'm going to read it out like that, so I can easily take the second derivative of this now using the chain rule. So the chain rule says we take this number, bring it down in front. So negative 2, x plus 1, you subtract 1 from the exponent, so that beats the negative 3, times the derivative of the inside. Well, derivative of x plus 1 is just 1. So that's simply going to equal negative 2 over x plus 1 to the third. And there's your answer. Okay, let's go to number 12 here. It says, how many derivatives can you take until the nth derivative of x equals 0? Okay, well, let's think about this. What really only matters here is the largest degree, that term. So that's going to determine when we can equal 0. So think about this logically. If we took the derivative of this, and let's just work with that first term here, well, that's going to end up being negative 24x to the 7th. Okay, and then if I took the second derivative, okay, we're going to do 7 times negative 24. Again, this really doesn't matter what this comes out to be, because this is going to end up being an x to the 6th here. Then if I did the third derivative, if I keep subtracting, this will be an x to the 5th. The fourth derivative of x will end up being an x to the 4th term, okay, and then so forth. So 5, 6, 7, we'll just keep going down. So x to the 3rd, x squared. The 7th derivative will be just x. The 8th derivative, okay, is just going to be some constant here, some constant value, okay, because it's going to be 1 times whatever this is. So that's going to give us that x to the 0 here. Okay, so x to the 0. But then to get 0, I need to go one more term here. So if I went f to the 9 of x, well, that's simply going to be just 0, okay? Because you're going to do 0 times whatever's in front. Derivative of a constant is always 0. So this is where we'll have our constant. So it's going to be n equals 9 there, when this would equal 0. All right, and then the last question says, determine the pattern for the nth derivative of y equals 2 over x. Okay, well, let's kind of just see what's going on here. So let's take some derivatives and see if we can determine a pattern. So 2 over x, remember, is the same thing as 2x to the negative 1. Okay, so let's do out a few derivatives and then see if we can come up with the pattern here. All right, so the first derivative, again, if we did this out, power rule, bring that down in front, would be negative 2x to the negative 2. The second derivative, negative 2 times the negative 2 is a positive 4, x to the negative 3. Okay, the third derivative here would be negative 12 x to the negative 4. The fourth derivative of this would simply be 48 x to the negative 5. All right, so let's start writing this down and see if we could figure out a pattern here. So it started out as 2 over x. Then it became negative 2 over, so this is just what y equals. So now we're going to look at our derivatives here. Okay, so the derivatives. Negative 2 over x squared. Then we got 4 over x cubed. Okay, then we got negative 12 over x to the 4th. And then we got 48 over x to the 5th. So what is the pattern? Okay, so the pattern for this then, first thing I noticed, so this is the first derivative, second derivative, third derivative, and then the fourth derivative. So I notice here that it's an alternating sequence, so that means I'm going to need a negative 1 to the n here. Okay, so we have that, and then we're going to have to deal with, let's see, this is times 2, then times 3, well, times negative 2 times negative 3, and then times negative 4. So that means that this is going to involve factorials here. So we're going to start it out, when we know it starts out with a 2, so it should be 2 times n factorial over x to the n plus 1. And there we go. That would be our pattern here for this. And if you wanted to, you can go ahead and test this out. Like, let's see if this works to give me the third derivative here. So if I wanted to find the third derivative using this formula, well, if I put this in, then that would simply be negative 1 to the third times 2 times 3 factorial all over x to the 3 plus 1. Okay, well, if I look here, negative 1 to the third would just be negative 1 times 2 times 3 factorial. If you don't remember, 3 factorial is just 3 times 2 times 1. So 3 factorial would be 6 here. So that would be times 6 over x to the 3 plus 1 would be 4. So that would be 6 times 2 is 12 times negative 1 would be negative 12 over x to the 4. Oh, and look, the third derivative was negative 12 over x to the 4. So if you wanted to find the nth derivative, fn, of x here, that derivative would be given by this formula that we have here. All right, perfect. So I hope that helps. If you have any questions, feel free to go ahead and email me there.